That's really what it means, though, okay? All right. Okay, so let me get back to the notes. You could also do the same thing if you left the max blank and filled in something for the minimum. Let's say for some reason you wanted the other direction. If you wanted, let's say, the percentage of all students who scored greater than a 6 on that exam, well, I'm going to put a 6 here, and this I'm going to leave blank. See, we get the other direction, which is still 0.5. You might see a plus infinity. You might see a figure 8 like symbol here. It's infinity, and it just means it keeps on going on and on and on and never stops. That's what it means. And that's just what this is saying. So as an example, if we wanted between what percentage of students scored greater than a 6, but let's say less than an 8. I don't know, I'm just making this up. You can see it's rough, it's a little less than 0.5. So maybe not 8. Let's try something like, I don't know, 6.5. Right? So this is the percentage of students who scored greater than a 6, less than 6.5. And you can see that's roughly about 0.4522. As a percent, you would have to multiply it by 100. Or move the decimal to the right 2 spaces. Okay. Well, let's work on this example now. So the next one I'm working on is example 7. You know, again, it's in the notes. I emailed it to you, to everyone, I mean. So again, it's the same data set, so the same normal distribution. What percentage of the students scored between a 5 and a 5.5? Okay, so what happened there? Well, let's see. Our minimum then would be 5. So we're looking at all the percentage of students that scored between a 5 and a 5.5. So we have 5 as the minimum. We have 5.5 as the max, and you can see it's over here. What I'm going to do is zoom out a bit, just a little bit. Okay. It's kind of hard to see, as you can see, because since the graph is very close to the x-axis, you know, it's a little hard to see what's going on. But if you zoom in, which is what, hold on, let me do this. Let me zoom in. You can see that the area is, yeah, between 5 and 5.5. This area turns out to be this, 0.04736. Now again, you want to convert that to a percent, and as a percent, it's about 4.736. I think that's what I have in the notes, and yes, it is. Good. Good. Okay. So that is what we get here. Are there any questions so far? Okay. Let me just do this then. Really hope everyone does this next time. Just playing around with Desmos. That's really what we're doing in the long run. I'm trying to show you, you know, what this tells us. I mean, there is actually a lot in the background that I'm not able to go into. So, which is unfortunate. There's a lot of calculus actually when you're dealing with stats and probability, so which makes it fun. Okay. All right. Okay. And again, I'll say this for people that came in after I started and missed this announcement. If you haven't handed in your exam, you know, again, please do so. You can email it to me, okay? I mean, you can, you know, I will accept it. I understand, you know, this is not an easy time being online like this. I understand that, okay? So I really hope everyone, you know, hands in their exam, so, okay? All right. So, okay, let me get back to the notes. So now I think you're gonna have a chance to try this. Not the hand in, So basically here, as you'll see, here it comes. So that's example 7, what I just did. This one I want everyone to try now using, Desmos, and then we'll go through it together. So basically I want everyone to do this. Take about 2 or 3 minutes. Okay. So I'm going to stop the recording and I'll set the timer for 2 or 3 minutes.